Dear ladies and gentlemen, and welcome to our today's webinar. My name is Stefan Ringbeck. I'm Product Marketing Manager for Trina Solar here in Europe. And today we speak about our dual glass PV module and the installation and handling. The presentation itself will take approximately 20 to 25 minutes. After the presentation, I will check the chat and the question pane for questions. So if you have questions, please write them in the question pane, and after the presentation, I will go through it and answer the questions. The presentation will be recorded and distributed after the webinars in the coming days. Today we will speak about certain points. So first I will give you some advantages of glass-glass technology. Then I will switch over to the installation methods, what is known in the market, what is available, what do we know from the past. Then I will switch over to the solutions, to the installation solutions which are offered from Trina Solar for their glass-glass modules. And at the point 4, we will discuss about the handling, and I will give you some tips and tricks how you can handle glass-glass modules easily. What is important today, we are speaking mainly about frameless modules, since in the market there are modules available as glass-glass modules available with frame and without, and all the installation methods what are shown afterwards are focused on glass-glass frameless modules, since the installation of framed glass-glass modules is the same like for framed glass foil modules, and therefore we focus on frameless modules. First of all, what are the advantages? A glass-glass modules or a glass-glass modules in general offer certain advantages. And some of the advantages you can see directly if you take a look on the warranty conditions. You see directly that the annual degradation is reduced to 0.5% and that the performance warranty is extended to 30 years. Why can we extend the warranty and why can we reduce the degradation? Also, there are several causes. One cause is that, for example, the backsheet, what is for glass-glass modules obviously glass and not a foil, is much more resistant towards environmental impact than a foil, for example, to acids or to humidity or to salt, which means the glass is always more resistant. And even the aging is reduced. Besides the advantages of the reliability and durability, for example, for environmental conditions, it also has some mechanical advantages. For example, glass-glass modules, you can see it as a sandwich. You have a glass front sheet and a glass back sheet, and in the middle you have the solar cells. The cells are in this or for this reason in the ideal position, and because the cells are close to the neutral phase. That means that if you're bending the modules, what is usual when you have the modules installed outdoor, that you can that the module is always moving and deflecting, is that the risk of having microcracks is way much reduced compared to glass foil modules, and that is one of the reasons why also the degradation and the reliability is way better with glass-glass modules compared to glass foil modules. Then as next, I will speak about the potential induced degradation, so-called PID. The PID is driven by the potential difference what you have between the active cell and the grounded frame. That means that, for example, if you have it installed in a hot tropical climate, you usually have, or you have easily a wet surface or a wet module. And if you have then a potential difference between the cell and the grounded frame, because the frame always needs to be grounded, then you build up an electrical field on the complete module surface, what is then leading to a diffusion process, what is the root cause for the power reduction and the degradation process. You can enhance the PID reliability with so-called anti-PID cells. So the cells are specially treated to reduce the PID effect on the cells. That means if you look here on the right hand side that the degradation due to PID is already way reduced. But if you're not taking a look on a glass module, a glass module has there's certain advantage. So first, you don't have in the frameless version, you don't have a frame, and the clamps or the next conductive part is much more far away from the cell. Because if you look here on the build up here, you see a framed module. If you take here the blue part, what is here displayed for the glass, you copy it to the backside. Then you also can see that the distance between the active cell and the frame is increased, which means that the impact or let's say the electrical field isn't so strong like for a framed module. This is also one of the reasons why based on the module design, frameless glass modules have the best PID, let's say, properties and the lowest degradation due to PID effects. This also shows in the test results what you can see here on the right side. If you're comparing a framed module with anti-PID cells and the glass module with anti-PID cells, you can see that the degradation is, let's say, reduced by minimum 50%, or in the second case you see it's only 0.24%. After the test it's close to 1/10 compared to a module with anti-PID cells. Then next I will go to the installation methods. I will give you an overview about known installation methods in the market. First of all, we have clamps. The laminate clamps can be compared with, let's say, standard module clamps. The laminate clamps are consisting always of several parts. So you have here a base part or bottom part, then you have an upper part, and you also have a rubber part or polymer parts or plastic parts to protect the glass from the aluminium. The clamp solution is the most common installation method known in the market. There's a good experience because it's also based, or it's also comparable to the installation of framed modules. And or one of the disadvantages is lower load reserves and the higher stress for the glass modules due to the increased bandwidth and the design. Then you have slide-in solution. That means you have here a special designed rail. You have polymer profiled on the edge, and then you simply slide in the modules. This can be also compared with slide-in solutions for framed modules, but here you also need additionally the polymer part to protect the glass edges. Which means here no more clamps are required, and you simply move it in, and then it's done. But it requires a special rail design. Further, we have so-called back rails and hooks. Also, back rails and hooks are close together. Back rails are going along, or mostly along, the complete length of the module or the width, and they are bonded with, for example, with a tape. But tape isn't the best solution. The better solution is, the best solution is using two-component adhesive, for example, known from the building industry. The advantage here is that you have a very good support, but you need to take a look on the material combination you use, because you have different expansion or heat expansion, thermal expansion factors between the glass and the metal. So for example, aluminium would be not that good because aluminium has a far higher heat expansion than glass. And if you're looking on the building industry or in the glass construction, steel is the material to use for the back rails to have a very similar heat expansion. Then the hooks, they also require a special rail design. They can be hooked in and also with screwless solution, or you screw them from the backside. And Trina also offers some kind of a hook solution. It's called Gecko grip, where we'll later on show the installation. Then, as a final method, is the direct bonding. The direct bonding in comparison to the other one requires the lowest amount of material because you don't have additional installation rails. Here, for example, it's shown that you install it directly on the sheet, on the trapezial sheet metal. The advantage is the lower material consumption, the extreme good load distribution because you have a lot of support points. But on the other hand, one of the disadvantages is what happened if the module is defect, it needs to be replaced because it's bonded and it's much harder to, let's say, remove compared to, let's say, a backrail solution or hook solution. Further, the question is about the quality of the bonding, because the quality needs to be ensured under, let's say, outdoor conditions, which means you have a higher impact on, for example, of the temperature and humidity. If you compare, for example, summer times with winter times, the viscosity of the adhesive will be way different due to the different temperature, and also the humidity can be let's say one factor, for example, for the curing time and curing quality. And most of the adhesives has, let's say, need a certain condition or a certain window for the environmental conditions to have the best curing and the best properties after they are cured to ensure the quality. And therefore, it's much harder to achieve it outdoor than indoor in a factory. Then, now I will go to the installation methods for Trina Solar modules and what Trina Solar is offering. So we have third-party qualified clamps. So we have clamp solutions approved and our own clamp solution. It's called Trina Solar clamp. Here you can see that the installation speed of the clamp or of the modules is 80 to 90 modules per day per 2 person, but usually the certified loads is plus minus 11 Pascal. For the Trina Solar clamp, it has the same installation speed of 80 to 90 modules per day, also with 2 person, and depending on the module dimension, a third rail is needed to achieve the first node loads of plus 5,400 Pascal. For the Gecko grip, here you can see it how it looks like. So it's a short metal rail with a keyhole where you can put in the screw head, and then you can screw it onto the substructure. There's the installation speed is doubled with 160 to 180 modules per day with 2 person, and the loads are certified for 2,400 up to 5,400 Pascal for pressure and suction. The Gecko group always came with the extended mechanical load test, the 5,400, and it has also further advantages in terms of design flexibility. Because everything what is bonded on the backside, you can design it according to the local loads. So you can, for example, increase the number of Gecko grips or back rails depending on the load what you expect on the side. And with clamps, this is not possible. That means with Gecko grips or in general back bonded solutions, you're able to have durable and reliable systems even in higher load locations. That means locations with high wind speeds or high snow loads. But for this, for sure, it needs to be designed and then according to the design produced. Now I will show you the installation. The installation of clamps and then afterwards from the Gecko grips. So you see here below a link of YouTube where you can see how the installation happened with the Trina clamps. So with the clamps, first you put the clamps or you install them on the substructure. That's here the step 1, though you put a couple of clamps on the substructure. Important is that the clamp is not completely closed, because in the second step you're sliding in the module. But here you also need to take care that the module is not hitting the substructure, because the module has a certain fragility, and the glass doesn't like to have hard impacts, because with the hard impacts there's the risk of having the module cracked and that the module break. Then as third step, you start tightening the screws. Later on I will show you how you do it from, let's say, a column to column, because you always have certain clamps closed and other ones open. With clamps, you usually need a person who is holding the module, since the module can slide down until the clamp is closed. What is also important here is see that in the first step, that means step 1 and 2, the clamp is open, and then you put in the module, and then you have to tighten the screw with a certain torque. In our case, it's 16 to 20 Newton meters, but this also depends on the clamp. For glass modules, it's very important to have the screws tightened with a certain torque, since a too low torque leads that the module can slide down, because you need a minimum pressure onto the polymer and then onto the module, that the module is not sliding down or slipping out. But if you're putting too much force on it, then you have a too high compression in the polymer, and then it's getting too hard, and you have the risk that your module break. Here you also see pictures of the end clamp and the middle clamp. Now, here at last step, I show how the installation process is. So here we have 3 modules. The first one is already completely in place. Here you have all the 4 clamps, so 2 end clamps and 2 middle clamps closed. Then you have the second one. Here, these 2 middle clamps needs to be open, that you're able to move in the third module. Here it's important that you usually have to have these clamps a little bit more loose than for standard framed modules, since you have the polymer what is compressing or needs to be compressed. And then you see here that several clamps are installed, and then you move the clamps toward the modules, that the module is completely supported and not falling down onto the substructure. Now we will go to the Gecko grip. The Gecko grip, as you can already see here, there's the keyholes. The keyholes have different orientation to prevent, for example, the module from sliding down, and you have a certain length what you can use for equalize tolerances in the substructure, in the holes and stuff like this. Here you have here you see also the potential savings for the L3. So you see, as mentioned already before, you have savings here on the variable BRS cost on the installation time, and some savings on the operation maintenance cost. But for sure the module is slightly more expensive because it has metal rails bonded on the backside. But overall you have the, let's say, you're able to have a more reliable, more durable project with a better predictable energy yield over the lifetime, because you also have lower maintenance, because for example EPDM will age with the time, it gets more hard. For example, also you know from your tires that you usually can only use your tires for the cars only 7 years, and then you have to exchange tires because the rubber is aged and quite hard. It doesn't have the properties like in the beginning. The same applies here for the clamps. That means a clamp what is consisting of more than one part needs frequently operation maintenance, and for the Gecko grip you only have to check that the screws are tightened. Further, if you're putting on what I will show later, if you put on if you lay down the module on the substructure, that you have lower risk of having hitting the substructure. Here you see the Gecko grip. In the first step, you're putting in the screws. Ensure that the screw is here in the center part of the keyhole completely, and not here on the edge or in the keyhole in the upper part of in the big part of the keyhole, to ensure that the unnecessary surface is given. Then on the second, you start moving the module onto the rails, and you align then here with the holes of your substructure. In the third step, you put down the modules here in the installation holes. The advantage here, if you don't have a third person to hold the module will stop here in the keyhole or in the smaller part of the keyhole, and it cannot slide down completely, which means if you have 3 persons, 2 persons can bring the modules, the third person can, without holding the module, can tighten the screws and making the electrical connection. Another advantage is the better load, the better deflection properties and stress distribution of the module. Here we are comparing a framed modules. you can compare it, for example, with a towel, where we have the most deflection in the middle. Then you have the Duomax model clamped. We also have high quiet, high deflection, and a very high span width between the edges. Here you see the deflection, that the deflection here is higher than here, and they for sure here will be the extreme point. And the gig groups, they are installed underneath the module. And you see that you have here lower deflection, and here also the lower deflection means that you have lower stress peaks compared here to the clamped one, because around the clamp you will have the extreme values for the stress on the glass, which means you have a better load distribution, higher load reserves, and better durability. Now, at last point for today's webinars, I will give you some points about the handling of the glass module, without tips and tricks. Our glass modules will come with a plastic corner here, the black part, and so-called edge banding. Edge banding is a little bit of EVA what is put on the edge to have a slide or light protection for the module. That means that if you have that doesn't mean that you can handle it like a normal friend module. So if you have a hard impact, it's still the risk of breaking it, but the plastic corner and the edge banding ensures that if you have light impacts, that it doesn't crack so easily. And according to our internal test, it shows that the breakage area get further reduced with the edge bending and the corner protection, and the breaking rate is approximately the same like with normal modules. But these 2 points doesn't mean that you can put it directly down on the ground or on gravels or on the wall. So since you always have material remaining from the pellets, it's always good to put, for example, wood, the carton, or even some kind of polymer, let's say, also on the backside or underneath the module, so that the module is not in direct contact, for example, with concrete, because you don't know if there are hard points or metal parts. So it's always good to have something protecting. If you're carrying the module, it's better to carry it with 2 persons. So you hold it on the long sides, and then you carry it with 2 persons. And for sure, the people need to take care that you don't have hard impacts. And you cannot directly staple the module, so you need always protection material. So the best is if you have a certain number of modules that you let them stay in the pellet. Because in the pellet you have let's say a certain distance, and they're stabilized so that they cannot touch each other. For handling the modules, and for example for carrying or positioning or even installing with clamps, so suction cups are quite good, because you have a better feeling about how to handle it. You don't harm your finger easily, so it's better to carry the module. It's easier to move it around. Then you also should wear gloves, rubberized and cut protected, because you always have sharp edges or can have sharp edges, and this is protecting your hands from getting cut. And for example, for clamp installation, you need Allen keys or wrenches, and for sure you also should wear your personal safety equipment, and especially safety goggles, since if a module breaks, that no glasses, because the glass can fly around, but it's the same for standard frame modules, that nothing is getting into your eye. That's already all. I will now quickly check for questions. Here's a question about the cell temperature due to lower heat transfer of the glass. The cell temperature is slightly higher because they have more capacity, because they have more weight, and therefore the cell temperature is slightly higher. And yeah. Do you have an optimized system to hold the string cables on the module? Depending on the orientation, we have two versions for our glass model. So one is coming with short cable for portrait installation and one with long cables for landscape orientation. With the short cable, it's quite easy to install them on the rails. The slides. There's another question. Are the modules have an embedded optimizer? So far, there's no optimized glass modules because our glass modules. I will go quickly a slide back. Or a few slides back. So with optimization, therefore there's no optimized glass modules because you can see that we have a split junction box, and that means that also the electronics, the PCB for the optimization needs to be split, and so far the known solutions are always on one PCB, which means there is so far no optimized glass module or no module with module level or string level optimization. Can you please email the minimum geometrical measurements for the beam to install the modules on? In the, let's say in the manual and on the datasheet, you find some information, especially about the distances between the installation holes, so where the screws are placed. And then you need to consider a certain minimum height that you can screw it on the substructure. And then with your substructure manufacturer, you're aligned for certain long holes to have a certain tolerance equalization. The last question here is about the PID. The PID for frameless glass modules is way improved compared to framed modules. And if you have, for example, hooks on the back side, then you have the maximum distance you can have from the active cell and the next grounded part, because you have the complete glass thickness plus the complete thickness of the adhesive. Okay, so I really want to say thank you for your attention. We will distribute the recording and the presentation after the webinar. I'm not sure if today, but in the coming days. And if you have questions, then you also can write me an email. My email address is stefan.ringbeck@trinasolar.com. Thank you very much for your attention. Have a nice day. Goodbye.